Okay, so what we're going to look at is all the parent functions that we're going to work on through the whole Algebra 2 year. And the first one is linear. Right? You see the graph that has linear? Okay. Linear functions is the first one we're going to look at. And a linear function is just this, x. Okay. Linear function x. So how do we graph that? Okay, so you get your graphing calculator. And on the top left-hand corner, you're going to push y equals. And all these like y equals should come up. And then you have an X button. It's right to the right of your green button here. It has an X on it. So you should have a y1 equals x. And then you're going to, on the top right-hand corner, it says graph. You push graph. And you should have this line. That's a linear function. That's the parent linear function. So how do we graph that? We just don't sketch the picture of it. We want points. So you go second graph, the yellow button, second graph, and you'll get this table of points. These are the points that are on your graph, and you can use your arrow keys, and you can scroll up, you can scroll down, and find points. So using that table, you would go on to here, and just pick points that you want to graph, probably 3 good points. So I would look at my table and think, oh, -5 is a good point. 0, 0, and maybe something like 3, 3. Those would be points I'd take from that table and write them down. So then you get what your parent function looks like. And the last thing on this is, what would the domain and range be? It's going left and right forever, so my domain is all real numbers, very good. It's going up and down forever, so my range would be all real numbers again. It's just an italicized R, is what it is. The next one is a quadratic. Quadratic function is an x squared. Okay. So you go to your y equals on your calculator, y equals.
Whoa.
So there's no back button, so you just push y equals. Clear it out. And now you're going to go x squared. And your squared button is the fifth one down on the left side. It's like below the green, the third one below the green. There's a little 2. You have to push X first, and then the squared button, and then graph. Not enter, graph. And you should get what? Looks like a U. Oh, no, you should clear out your first one. Yeah, clear out your first one. So you should get this U looking thing. Anyone not get a U? Everyone got a U? Okay, good.
It's still doing it.
Okay, so I would want this table, right? So you go second graph, and there'd be some good points. You'd want to do negatives and positives on your x's, so you get both sides. So something like -3, 9, 2, 4, right? Something on left and right side.
What if we just use what it gives us?
You might want to get some negatives though, because you're going to want both sides of that U. So the only way to do that is to get some x's, -x. You'd want 0 for sure, 0, 0 for sure, because that is, remember, your minimum. Remember, you have a minimum on a parabola. So 0, 0 you'd want to make sure you have that point. My domain and range. So domain, how am I going left and right? Am I going left and right forever? So all real numbers.
Yes.
What's my range though? If you notice your range, I'm starting here and I'm only going up. So it can't be all real numbers because I'm only here and going up. So I'm starting at the origin, 0, 0, and only getting bigger. So your range would be greater than or equal to 0. 0 and bigger. second graph. And that's a table. All right, cubic. Cubic, if you've probably guessed it, is going to be x cubed. There's two places to find a cubed button. So go to your y equals, clear it out, push your x. Now, you can do two ways you can do cubic. You can do caret 3, and that's the way to cube it. Or if you go under math, the third one down, there's a little 3. That's also a cubed. So either one you want to do. If you want to do x caret 3 or x and then math and use that cubed, it should get you a cubic. And then graph. And you should kind of get this S looking thing, right? So go into your table, second graph, right? Second graph, go into your table. And then I'll tell you some points to graph, like -8, oh no, -2, I'm doing cube root. -2, -8, that's a point, 0, 0. 1, 1 would be a point, 2, 8. You can get that all from your table. So then when you graph it, it looks like that. Domain, how far left and right am I going? It's harder to see, but I am continuously going left and right, so it's all real numbers. In my range, that one's easier to see. I'm going up and down forever, so that's also all real numbers. Right. Next one is the quartic, and quartic is x to the 4th degree. Right? Quartic, 4 quarters in a dollar, 4 quarts in a gallon, quartic. And this one you have to use the caret. You go to your y equals, clear it out, and you're going to go x caret 4. There is no other 4th degree in there. And it should look a lot like a parabola, only skinnier. Because what happens with the 4th degree is it blows up faster. So when you graph it, it should look very similar to your quadratic. It should still have 0, 0, 1, 1, -1, 1, but then like 2 is 16. So there's not very many points you can graph before it gets too big. And then it should be, if you see, it's like really, it's a lot skinnier than your quadratic.
What's the domain and range for the last one?
All real numbers for both.
Okay,
so this domain range is going to be very similar then to the quadratic because they look the same. I'm slowly going left and right forever, so all real numbers. But again, the range is distinct because I'm starting at 0 and only getting bigger. So my range would be y is greater than or equal to 0. Right, just like the parabola, so I'm only going up. Square root. You've worked with square roots, maybe just not the graph of square root. So you go to your y equals, clear it out. Your square root button is the 5th one down, but you have to go second that to get the yellow square root. So you'd go second and then that squared button to get that square root and then the x. So y equals, clear it out, second to get the square root, and then put in your x and then graph. You'll see this x squared button you used? Do second that. See the yellow square root, this yellow radical? So you got to use second to get that radical. And then you push x. And you should get this thing that starts at 0, 0 and just goes out. Did you guys get that? Kind of like the start of a rainbow. Okay. So let's go to our table. And you should notice on the negative x values it says error, because you cannot square root a negative number. Not yet. We will, but not yet.
Oh, error.
Okay, so you have to go to your positive x values. So 0, 0 is the first one that works. 4, 2, 9, 3. Right, those are, you have to kind of scroll to find some good points. And you should kind of get that half rainbow looking thing. Now the domain and range are both very specific on this one. Because if you look at the x values, it's starting at 0, 0 and only going to the right. So it's not all real numbers. So when I start at 0, 0 and go to the right, are my x's getting bigger or smaller? Bigger. So my domain is greater than or equal to 0. I'm starting at 0 and I'm only getting bigger. The y is very specific too. I'm starting at 0, 0 and I'm only going up. So my y is also greater than or equal to 0, which means that x's and y's have to be positive to do a square root. And that should make sense. You can only square root positive and your answer is only positive. So your whole graph is only in the first quadrant. Good? Okay. Cube root. Cube root looks like this. It's the function, and you have this little 3, and then the radical sign. That means cube root. And you find the cube root in the math button. So go to y equals, clear it out, and you go math, and it's the fourth one down. It's a little 3 with a radical. That's your cube root. So cube root, and then you push your x, and then graph. And it should look like your cubic, but only it got flipped on its side. Then you can go second graph,
Mine's not working.
get some points. It isn't working.
Whenever I push enter, it says error.
Okay, so you graph those points. -8, -2, -1, -1, 8, 2. Like I said, it should look like that cubic function, but it only got flipped on its side. Domain, I'm going left and right forever, so all real numbers. Range, it's harder to see, but you are going up and down forever. It's just a slower incline, decline. So that's also all real numbers. Good, next one. 3 more. Absolute value, you've worked with this function before. If you remember, absolute value is the straight lines. That means absolute value. It's not curved, those are parentheses. Straight line, right? Absolute value. Now this one's tricky, you gotta pay attention. I'll show you the absolute value. Go to y equals, clear it out. Okay. You're gonna go to math. And then you're going to right arrow over to the next tab, and it should say abs with a parenthesis. That's your absolute value. Everyone find it? So you're going to push enter on that, so on your Y1 you'll have abs, and then you can push the X, and then you can graph it. And this is the one where you should get the V for vermilion. Everyone with me on that one? That one's a little tricky to find. So then you can go second graph again, and get some points to graph, like -4, 4. I would include 0, 0, because that's your vertex. 6, 6, something like that. And this domain and range is going to look very similar to your quadratic, because instead of a U, it's a V. but it's still starting at 0, 0. So I look left and right, and it's going left and right forever, so my domain, all real numbers. But the range, just like the quadratic, I'm starting at 0, 0, and I'm only going up. So it'd be y is greater than equal to 0. You're starting at 0, 0, and you're only going bigger. You're going up. The next two are kind of fun. These are graphs you've never seen before. We'll do these second semester. Exponential and rational functions. Exponential looks something like this. Instead of x being your variable or a coefficient, it's now going to be a power. Okay, this is the first time you've ever seen x as a power. So to put this into your calculator, you go y equals, and you're going to go 2 caret x, 2 to the x power. And you should get this kind of like this slide looking thing. It's just going to blow up fast. Exponential functions, a really good example would be flu virus. 1 person sick, 5 people sick, 100 people are sick. Right? That's exponential when it just blows up. So then you can go to your table and pick some values. -1, 1/2, 0, 1, 2, 4, 3, 8. And what happens, it's kind of hard to see on your graph, but what happens is this graph is going to get closer and closer and closer to the x-axis, but it's never going to cross it. The x-axis is what we call an asymptote. We'll study those later this year. It's a line that a graph never crosses. It's going to get closer and closer and closer to it, but never cross it. And we'll study those, like I said, later. So it kind of just blows up like that. So the domain and range are going to be a little bit different on this one. Domain, you can see how it's going right and left forever. So domain, again, is all real numbers. You can put any number in for x. But range, it's starting at the x-axis and only going up, but since it's not touching the x-axis, we can't use the or equal to. We can only say that it's greater than 0 because it does not touch the x-axis. It only is more than 0. That's it. And the last one, rational function. Rational function will be now the first time that you see x in the denominator. Okay, so go to your y equals, clear it out, and it's 1 divided by x. That's a rational function, and this graph is kind of neat. 1 divided by x. Okay, kind of a neat graph, something you probably have never seen before. So then if you go to your table, what you'll notice is that you have an error on 0 because what happens is both the x-axis and the y-axis are asymptotes. It doesn't cross either one. So if you pick some points, there's not going to be very many points to graph on this one. This one's going to be more of a sketch. Just because your numbers get so small and so big fast. In domain and range, this one's going to be opposite. Because what happens is that x values, x can be any number until it gets to the y-axis, and then it stops. And then it picks up again and then keeps going. So my x's can be anything but the y-axis. That means it can't be 0. So instead of saying what x can be, we're going to say what x can't be. Domain is everything but x cannot be 0 because it does not cross the y-axis. And then the range, again, it can be any y value, and then it goes off, comes down and goes off.
The sign on the name. What is that?
Cannot be. It's like an equal sign with a slash.
Oh,
So my range would be y cannot be 0 because it doesn't cross the x-axis. So in this case, it was easier to say what the domain and range can't be than can. And sometimes that happens. So that's what we're going to be doing this year. Those are all the parent functions. Yay. Can't wait, Ms. Chapman. It's going to be so much fun. All right, let's do a couple of homework together. It's not hard, but I know it's a little confusing when you look at it. What am I wanting here? What I want is for you to look at the picture of the graph and identify what parent function it came from. Right? It's not going to look exactly like the parent function because there's some transformations, but you should be able to look at them and know where did it come from, which one did it come from. So if you look at this first one, it's going down on the left, up on the right. What parent function is that? Cubic. Very good. What is the domain and range for cubic? Very good. All real numbers for both. And then I threw in some function notation to practice one more time. Remember how to do this. This is saying when x is -2, what's y? So I could graph a line here, x is -2, and where it hits my graph would be the y value. So when x is -2, what's y? 2, good. When x is 2, right, that's over here, what's my y? 0. That's what you're doing for all of them. Do one more together. Then what's the next one? What's the parent function is that? Cube root. Very good. This is a cube root function. What's my domain and range on the cube root? All real numbers for both. Very good. This one, it's labeled for me. When x is -4, so I'm looking at this point right here. When x is -4, what's my y? -2. When x is 5, that's this point here. When x is 5, what's y? 1. That's what I'm looking for in all of these. Just what's the parent function? Use your notes, right? What's the domain and range? And then just a couple of function notations to practice again.